Good morning, everyone. This is July 22nd, 2016, and we're going to host a fairly informal online workshop around JupyterHub. We're going to try to look a little bit at what JupyterHub does at the architecture of the system with an introductory talk by Min, and then we're going to go through a series of short lightning talks describing scenarios and use cases for the system. And hopefully this will serve to sort of collect, both for users to collect kind of a gallery of scenarios and tools that have been developed to use JupyterHub in various environments, and also for us, for the team, to understand what are the various kind of common problems and pain points, and what are similarities, and what is happening in the ecosystem, both so that we can integrate better and so that we can identify problems that may need to be solved. So I'm not going to spend too much time doing a lot of introductions because we have a lot of people. So I would rather, without further ado, let Min, Reagan, Kelly take the first call. Min was the original architect of the project of JupyterHub, and he's been with us for a long time. Many people on the project know him. Min, have at it.
Yeah, so I'm going to start us off by talking a bit about setting the stage with the general JupyterHub architecture and how it works, what pieces we have, and then a little bit about where it's going and what people can do with it. Okay, and just checking everybody can see my screen with the first slide and that's working. All right, good. All right, so I'm gonna start talking about the architecture itself and kind of how JupyterHub works and what's there. So we start out, as I almost always start out, with kind of what is a notebook. And as far as JupyterHub is concerned, you start out with, the notebook is this document format, and it's also the environment in which you create the documents and run your computations and things. But most importantly for JupyterHub is it's a web application. So a notebook server is this web application where you have a Tornado Python notebook server, and then different kernels in different languages, Python, Julia, what have you, talking over the network. And then we view this whole thing as a single multi-process web application that users connect to over HTTP or HTTPS and WebSockets. So from that perspective, what is JupyterHub? JupyterHub takes that notebook and adds some extra pieces to it. So JupyterHub manages authentication, so that users can log in and use their notebooks with authenticating as themselves. And then it spawns single user servers on demand, so each user has their own notebook server. And for each user, there's one of these entire web applications that is the same application that you use when you type Jupyter Notebook on your laptop, or that you get with temp and B on try.jupyter.org. But then JupyterHub adds this authentication and spawning to let you deploy notebook servers for your users in various contexts. So the gist of what happens when a user visits JupyterHub, the initial request goes through this configurable HTTP proxy and is handled by the hub. The hub presents some form or uses OAuth to authenticate the user and identify them. And once the user is logged in, the spawner starts a single user server for that user. And then once the single user server is up and running, then the hub notifies the proxy to add another route so that this user / name URL points to the individual's single user server. And then the hub redirects the login page to the URL that is mapped to their particular server. And then the only modification that JupyterHub does to the single user server from what you get when you type Jupyter Notebook is that it adds, when you hit a notebook, it does some verification with so the hub set a cookie on that URL, and then when the single user server gets a request with that cookie, it asks the hub if that cookie corresponds to the user or users who should be allowed to access that server. And the important part here is that the Authenticator, which is the class that implements authentication, is customizable, and the spawner, the class that implements starting notebook servers, is also customizable. So you can, JupyterHub ships with some basic implementations, but you can use anything that can authenticate users, and anything that can start processes can be used in a JupyterHub deployment. So a bit about when you should use JupyterHub. So you can have, if you have a class where students want to do homework, you can deploy JupyterHub with NB Grader. If you have a short-lived workshop just teaching, you can, especially if installation of your tools is hard, you can use JupyterHub to give people access to some resources. Or if you're a research group and you've got a shared workstation or small cluster that different researchers should be able to use, you can have JupyterHub present an access point to that. Or computing resources in general at an institution for researchers, students, analysts, whatever. The general principle is you have computational resources and you want to give users access to that, and they should have their own space to work in, and things should be persistent, and they should be identified as specific individuals. So when not to use JupyterHub, this is important as we have a variety of things that and the existence of some other services let us kind of scope limit what we want to do with JupyterHub itself. So one is the basic principle of JupyterHub is that the notebook servers that users get in their work environment is authenticated and persistent. That means users log in, it's their stuff. When they leave, they should expect that stuff to still be there. There's also tempNB, which has a lot of things in common, but importantly, tempNB is anonymous. You just visit try.jupyter.org and you get a notebook server, and then when you leave for a while, that server is gone, and it doesn't save your work or anything. It's just kind of for trying things out and demoing things. And then binder is basically tempNB plus preloading the environment based on GitHub repos. So it's useful for demonstrating, providing interactive documentation with for packages, so that you can actually do live demos for people who don't have to install your software, or if you want to, do a reproducible research, kind of follow along with my computation without going through the installation process. And then there's Sage Math Cloud, which most importantly is hosted. So it's a commercial offering that has hosted notebooks and other things, and also provides real-time collaboration with in projects, and then a variety of classroom features for using in education contexts. And the two biggest points for Sage Math Cloud are that it's commercially supported, so you can have Sage Math, you can, rather than doing your own administrative sysadmin work to deploy JupyterHub, you can pay William Stein to do it for you on Sage Math Cloud. And also the real-time collaboration feature, which is important, and we still don't have yet. So the default behavior of JupyterHub, the authentication uses PAM, the Linux pluggable authentication module, which means it's just local users and passwords for logging in. And then the spawning is just to become a real user on the system and then start the notebook server. And because of this in particular, the hub must be run as root in order to have the permissions to become other users and launch servers as them. There's a pseudo spawner that lets you do this with slightly less than root privileges. But in general principle, the hub needs significant privileges in order to run in this way. So a bit about custom authenticators. So if you on your system want to use an authentication that is not the basic PAM, there's two general categories of authentication. One is username and password, where JupyterHub will show the user form with a username and a password field. And then your authenticator just needs to implement one method that takes data will be a dictionary of the form data from that HTML form, and you can get the username and password out of that, and then you do whatever it is that you do to verify that username and password. And then if authentication is successful, you return the username, and if it's unsuccessful, you just return none to identify that this information does not identify any particular user. And that's really all you need to do to implement a custom username and password authenticator, is just to write that one method. The second type, and perhaps more common, I think, is using OAuth. And we have this Authenticator package that is on the JupyterHub org, but not part of the JupyterHub base installation. And Tornado and Authenticator provide some base classes for implementing anything that does standard OAuth flow. You just need to give a couple of URLs, and then you have a login handler that's the HTTP handler that redirects to the OAuth service, and then the Authenticator is the Authenticator class that defines. So with OAuth, you visit a URL on your server. That URL redirects to the OAuth service, and then after logging in, that OAuth service redirects back to another URL on your system, which is where this Authenticator will get called. Typically, this has some short-lived code passed in the URL arguments, and then you need to take that and then ask the service with an API request, kind of who is the user that this code corresponds to. And then again, you just return the username if that is a successful authentication, and return none if it isn't. So custom authenticators that exist, are just some examples. Our Authenticator is a package that provides a collection of implementations of OAuth and a base implementation for people to subclass and extend. So it includes GitHub, Google, Bitbucket, Wikimedia, GitLab. Yeah. And then there's remote user, which can be used to just, you have some proxy, Apache or Nginx or something that's sitting in front of the JupyterHub application. And that handles its own authentication, maybe using a campus shibboleth plugin or something like that. And that just sets the user header so that essentially the hub isn't doing any authentication. It's just looking up the user header and trusting that the proxy in front of it is doing authentication. And there's LDAP Authenticator, which is talks to LDAP directly through the LDAP API rather than sometimes you can use LDAP just through PAM. There are examples of that, but sometimes you might want to talk to LDAP directly. But you can write more authenticators using either of these patterns with relatively little work based on what exists already. So an example of using GitHub OAuth is you need to go to the GitHub site to create an OAuth application, and then you'll need to pass a particular callback URL that the JupyterHub expects, and then you get a client ID and client secret that identify your application to GitHub, and you use these to set some environment variables to configure the GitHub Authenticator, and then you install the Authenticator package, and then in your JupyterHub configuration file, you tell it to use this Authenticator class, and then you're done, and you've got GitHub authenticated JupyterHub. By default, the default behavior of JupyterHub is to allow any user who successfully authenticates is allowed to have a server. That's usually fine with PAM because anybody who has access to that server already can have access to that server through JupyterHub. That generally makes sense. But if you're using GitHub OAuth, that makes significantly less sense because the odds of you wanting to allow every user of GitHub access to your machine is significantly less. So authenticators have a notion of a whitelist, and this is a whitelist of usernames as interpreted by your authentication service that should be allowed access. And then there's also a list of admin users who should have access to the admin interface of JupyterHub, who can do things like add and remove users, do some debugging, stop and start other users' servers, that kind of stuff. So a bit about what spawners need to be able to do and how to do a custom spawner. The most basic functionality. Yeah.
In the OAuth Authenticator, is there a way to modify that list while the server is up? Because it seems like it reads that list when during startup, but I didn't see how you would update that list in real time.
Yeah, something that I didn't entirely plan to talk about, but the config file is essentially used to initialize a database. And then there is an API, a REST API that you can use to add users, add and remove users in that database. And so any user that is added via the UI will get added to the whitelist. So adding a user is effectively adding a user to the whitelist. So the whitelist in the config file is really just an initial condition for the whitelist. And then any users added can be added later at runtime. And then the next time you start the server, it will load from both sources the whitelist in the config file and anything that's been added to the database. Does that make sense?
Okay, yeah, thank you. That makes sense.
Yeah. So once you've got a user that's identified as a username, and then you implement a spawner is the object that represents starting a notebook server. And there's a base class for this, just like there is for authentication. So writing custom spawners, you subclass this, and you mainly define 3 methods. So start is a method that will start the notebook server, and there will be there are some methods on the base class for the arguments to pass to the notebook server and the environment variables to load into the environment. And then you implement the function that is kind of, so how do I actually start this, which can be, allocate an EC2 instance, submit a PBS job, any of these things. And it must be a tornado coroutine for async reasons. So a lot of these spawners might take a really long time to start a server. So you can use these yield statements to start a server, to request a server, and then you don't return until that server is actually running. And then the main thing that your spawner needs to do is communicate to the IP and port of the server so that the hub can add that entry point to the proxy. This can be any IP and port. JupyterHub doesn't care anything about how you start the notebook server, other than you start it somewhere that is accessible on the network to where the proxy is running. And then you pass that in the next release of JupyterHub, you'll pass that just by returning the IP and port in the current stable version. You set these with setting attributes on the user server ORM object. And the remaining methods, so once you've got a notebook server, you have to be able to poll, you have to be able to check if the server's still there, and then you have to be able to stop it when the user asks you to stop running the notebook server. And then some extra methods that that are kind of optional, that in general the hub you should be able to bring down the hub and leave your single user service running, and then bring the hub back up, and it can reload its state from the database. In order to do this, it needs to be able to reconstruct whatever state the spawner had to reload the spawner from the database, so that it can continue polling and stopping without having been the actual object that started the notebook server. And so these are just load state, get state. So the state can be any dictionary of state. So I've included the examples from the local process spawner, where the state for the spawner is just the PID of the process. And so you save the PID so that you can reconstruct a new spawner from that saved PID, and it can start, stop, kill, or it can poll and stop just given that PID. But whatever information you need to reconnect to your spawner is what you would use here. It's the container ID on Docker, that kind of thing. So an example of using Docker spawner. So one of our example custom
Sorry,
spawner.
I had a quick question about the state thing.
Yep.
Is there a way to share that between an authenticator and a spawner?
Share the state. So the authenticator has 2 hooks. I believe they're called pre-spawn start and post-spawn stop, that are called with the spawner kind of before and after it starts. And that lets you do things. You can have spawner authenticator pairs that need to pass information. So there's the CI logon authenticator and spawner pass credentials using this. So the authenticator logs in, it gets a client certificate, and then during this pre-spawn start hook, it passes that certificate to the spawner, and then spawner.start loads that into the user's environment. So it's In that case, the authenticator and spawner do need to know about each other. It's really an authenticator spawner pair. They don't necessarily work with it. It's not, because that behavior is not something general to all notebook servers. That's a feature that that spawner class and authenticator class both know about, that they pass between them through this hook. But yeah, there is a mechanism for the authenticator to pass information to the spawner. And the spawner does actually have a handle on the authenticator when it starts, if it needs to get information out of it that way.
I noticed I actually looked at this is Shane Cannon, by the way, I just came in a little late. I actually looked at your code when we were working on the GSI one, and you had something that I think generically would be useful, which is being able to tell the spawner what URL to contact back on, because the one that's in JupyterHub may not be the right one that you want to sort of tell the spawners to use. So that may be something that would be generically useful to push up higher into sort of the template or whatever. Yeah.
So in general, JupyterHub does encode kind of the IP and API URL of the hub. Generally, the only thing you need for that is an IP address or an IP import that the hub is listening on. And so if you set the hub IP, for instance, that's generally accessible.
Right. Where it gets tricky is when when the hub itself is running in a container. And I think you even mentioned that in your code, because the internal address that it's going to,
with Docker in particular, the best way to do that is with Docker overlay networks. Makes it a lot. That basically lets you think about it as a regular network when both things are in containers and they're on. If you use Docker links or Docker overlay networks, then you just need to pass basically the host name of the hub container.
Yeah, in our case, we're running the hub in a container, but then the spawners run externally from Docker. Yeah.
Right. Yeah, and in that case, there's a when the environment in which the hub is and the environment in which the containers or the spawners are running, then there may be something specific to the spawner that you need to say. The hub doesn't actually know where itself is relative to the spawner, but the spawner does. Right. And so Docker in particular has what it's called the hub. Docker spawner actually has its own configuration for overriding the hub IP.
Yeah, that's what I saw.
Hub connect IP, I think, is in Docker spawner.
Yeah, and I wound up kind of reusing some of that logic.
Yeah, we could push that up into the base spawner class. So since that you're right, that is generic to. Actually, I haven't seen it be relevant except for Docker, but it conceivably could be. That we can push that configuration up to the base spawner class. Plugging along. So this is, in general, this is actually related to that. In your config file, loading the Docker spawner is often not enough because the hub API that the spawner uses to check with to authenticate with the hub, it listens on localhost by default because we don't want to give other machines access to that API unnecessarily. But often, if you're running in Docker, that's not actually enough. So if you're running the hub on the host and your containers in Docker, this bit of code in the config file tells the hub API to actually listen on the Docker virtual interface so that it's accessible to Docker containers. And in this case, you don't need any configuration, any special configuration of the spawner. You're just telling the hub's API to listen on this interface. And that interface is accessible to all containers. And the Docker spawner in particular has tons of configuration that you can use. You can load data volumes. You can specify the container image. and you can do a bunch of networking configurations to give different containers access to different services, including the hub itself. So more custom spawners that we have, there's the Docker spawner, which I talked about. Sudo spawner lets you run the regular local users without giving root permissions to the hub. That one is kind of, I don't recommend using that unless you really have to, because it's really hard to configure and debug. Batch spawner lets you spawn servers with batch systems, and remote spawner lets you run remote servers over SSH. And there's more, and you can write your own without too much effort. So then a bit about deploying JupyterHub. You can install it with conda, pip, npm. It does have one non-Python dependency. So if you can install it in one command with conda if you use the conda forge channel, or you have to install the Python package with pip, and then the JavaScript package with npm for the proxy. Caveats for installation. Often, if you install things in ends, those ends aren't readable by all users. So you need to be really careful if you're making ends for JupyterHub that are owned by root and private. That won't work. You'll need to make sure that the JupyterHub installation itself is accessible to all your users when you're using local local single user servers. Always use SSL, since this is an authenticated service where people log in, run code. Just don't run it over plain HTTP ever. And you can use self-signed certificates, but one caveat there is that Safari refuses to connect WebSockets to untrusted certs. But the solution to that is Let's Encrypt, which provides free SSL certificates for any domain. So if you have a domain, then you can use SSL with JupyterHub. Or you can do SSL termination at Nginx or Apache or something.
Hey man, do you know if the hub API URL, is that encrypted as well? Because I thought that was...
No, the local, what are considered local internal services are all still HTTP only. That's mainly just a lack of exposing configuration. There's no actual restriction. And we actually really want to set up PKI for for authentication with not just SSL encryption, but actually SSL. I don't know what the right actual words are, but actually set up authentication like the Docker daemons do, so that the clients actually get client certificates to authenticate their API requests. But that we haven't gotten there yet. It's mostly it's mostly a matter of the servers, Tornado servers, and everything we use support all of that. It's mostly just a matter of exposing those options at the command line and config files in order to do it.
We should talk offline, because I think there's one of our use cases involves running a hub remotely and having basically spawning notebooks potentially on a different network.
Yeah, then you definitely want SSL on the API, and we can. It's not hard. I just there's a lot of things. So
Yeah.
definitely
So let's
we can definitely talk about that. Yeah, it's definitely not hard. Well, the PKI stuff might be a little bit hard, but just turning on SSL is not hard. We just need to expose the options. So the basics of running with SSL. So this would be the config you need to run with SSL on the default HTTPS port. And you do generate config to generate your default config file, just like all the other Jupyter applications. More things, for the system-wide installation, you want to make sure that you install kernels and kernel specs system-wide, which may not be the default behavior for some kernel installations like Julia and R. So you want to make sure that those kernel specs are installed system-wide. The same is true of extensions. You can install and enable extensions system-wide as well for JupyterHub users. Generally, it's a good idea to run JupyterHub with some service management thing, whether it's services, supervisors, what I use most often. It's a process. It's a long-running process. So whatever service management tool you use, you can run JupyterHub with that. We don't. It doesn't really care how you start it. So it's a good idea to run with whatever tools you're familiar with. And we have 2 reference deployments, one for deploying Docker. With Docker, that uses Docker Compose, puts everything in Docker. And then we have one that's an example deployment for teaching that uses Ansible, doesn't use Docker, and sets up NBCreator on a local machine. General best practices, always use SSL. So the default is to use SQLite because that's the only thing in the Python standard library. But it's a good idea to use Postgres or MySQL or something if it's available. You can put Nginx or some other plain web server in front of the configure proxy to serve static pages. There's a call idle service that can prune idle servers to save, reduce resources if you have a lot of users, but few of them active at a given time. You can put Jupyter and IPython support system-wide configuration in etc Jupyter and etc IPython. You can put the configuration files there, so they'll affect everything. And then just backup user data is always a good thing to do if you're, especially if you're using Docker and things like that. Mentioned before is there's this REST API that you can use at runtime and with external services to manage Jupyter itself. You can add users, remove users, start and stop user servers, create new authentication tokens, talk to the proxy, shut down the hub itself. And a bit about where we're going, what's coming. Services is the next major milestone for things like the call idle servers script and NBCreator, make those easier to run and manage. These are things that talk to the JupyterHub API and may or may not be started by JupyterHub itself. And then the next thing, once we've got services, is a sharing service for users to publish notebooks and download notebooks from each other. And then the next thing is allowing multiple servers per user. Right now, we restrict users to 1 server, but that's an artificial restriction that we can relax. Yeah, and that's what I got for JupyterHub. Only a little bit over time.
Thanks a lot, man. No worries. There was a lot of good discussion and we started a couple minutes late. So I think in the interest of sticking to the schedule, since we have time, we have a solid half hour at the end. I probably want to pass it on to Brian, who has the next slot, and then we'll kind of keep open discussion for the final round.
Great.
Hi, can folks hear me?
Yes.
Let me share my screen here. You see my screen?
Yes.
All right. So I'm Brian Granger. I'm one of the core Jupyter devs, and I'm going to be talking about my experience in deploying JupyterHub. And one thing that I think is really important, and probably the main point that I want to make, is that in any context where you're deploying JupyterHub, there's a lot of decisions you need to make. And my deployment focus here is small to medium groups of mostly trusted users, and where the deployment is being managed by a non-DevOps type of person. And I'm a professor at Cal Poly, and in addition to helping to develop Jupyter, I also regularly teach classes in data science and physics where we're using and deploying JupyterHub. And so I sort of have these 2 roles myself, both being a developer of Jupyter, but also a user of Jupyter as well. And so the biggest thing that I think you'll encounter as you deploy JupyterHub is questions. There's a lot of questions to answer. Are you going to use the Docker spawner or not? Which authenticator are you going to use, PAM or OAuth? Which spawner, I guess that's the same as the Docker. Are you going to run a proxy like Nginx in front of JupyterHub or not? How are you going to install and manage kernels? Are you going to use Conda? Are you going to use the built-in system Python? Is NBCreator needed? How many users? What are the hardware requirements? And this is, I think, where there's still a lot of unavoidable pain in deploying JupyterHub right now that there are all these questions, and I think the main point I want to make is that the answer to these questions will depend highly on what usage case you want to support. And my particular usage case has the following characteristics. So there's no professional or first-time DevOps person. When I'm in teaching mode, I'm spending most of my time teaching a course, and during that quarter, I have essentially 0 cycles to spend on DevOps, sysadmin type tasks. And so my deployment is sort of optimized for that time requirement and expertise level. I typically have between 50 and 100 users across 1 or 2 or 3 sections of a given course. If we were ever in a situation where we had more than 100 users, they would be spread across multiple sections, and we could just deploy multiple servers. And so basically, we're finding that sort of 1 to 2 sections per server works well. And also, my users are trusted. By that, I mean I'm completely comfortable giving each of them a standard UNIX shell account on these servers. The other is that because of the constraint on numbers and also the memory and disk space requirement, I can always get away with a single server for a given JupyterHub deployment. And as other people will be talking about later, the effort that goes into scaling JupyterHub across a cluster is much more complicated, and I'm definitely avoiding that. But the deployment must be repeatable. So we're doing this deployment 1, 2 to 3 times per quarter, a few times a year. So it's something that we do often. And the persistence is really important. Students are doing a quarter worth of work on these systems. And so their work, I have to be able to guarantee instructors and students that their work will not ever disappear. And so they need to have persistent home directories that are backed up anywhere from daily to weekly. And then optionally, depending on the deployment scenario, a full NB graded deployment with multiple classes and instructors. This particular usage case, minus that last point about NB grader, I think also maps onto a lot of small research groups and data science groups in the industry. And so even though a lot of this goes under the heading of deploying JupyterHub for a teaching context, I think a lot of it would apply equally well to non-teaching contexts that have these same constraints. So again, I really want to emphasize the constraints here. I am simultaneously or often teaching the courses I'm deploying JupyterHub for. I have no TAs, no grad students, no sysadmins. I do absolutely everything. These courses take at least full time, but just for the instructional part. And so I have 0 time to mess with DevOps during the quarter. I have to have a solution that truly, truly just works, and that I'm spending a very, very small amount of time setting up each quarter. So what we've gone with for this scenario is an Ansible-based deployment. We've encoded all the choices and the constraints for this type of usage case as Ansible, configurable Ansible roles. I'll show you the GitHub repository where all of this sits in just a second. These Ansible roles were originally developed by Jonathan Frederick, who's a core Jupyter contributor. And then in recent times, I've sort of taken over that. And then now that it's merged into the JupyterHub org on GitHub, Min and a few others have started to contribute as well. And I've probably deployed myself, I don't know, half dozen servers now over the last year using this approach. And at this point, the new server build time is less than an hour. Honestly, the most complicated part for new people using this is simply getting a domain set up and getting SSL certs. Like that's typically getting DNS set up. Once that's done, it goes really fast. Originally, we were using the default Ubuntu Python, and it was taking a long time to just build and install Python packages. Min, what's your sense of how long a build is taking now now that we're using Conda for Python in this approach?
Probably closer to 15 minutes.
Okay, so you're basically looking at a new server from scratch. That is, once you have an instance up with a fully qualified domain name, DNS set up, and an SSL cert set up. So very quick turnaround time. Some technical details. We're using the sub-process spawner that uses just plain Unix user accounts. We're using the GitHub Authenticator that maps those Unix users onto the GitHub usernames. There's an Nginx proxy in front that does SSL termination and also serves static files related to the notebook server. And then we assume that you're using a real signed SSL certificate, either one that you've obtained usually through purchase, or we have a configuration that will just use Let's Encrypt. So we try to make this as easy as possible. The persistent services that need to run are run using the supervisor package. And then that's not Condo, it's Conda for Python packages, and with occasional usage of pip for non-Conda available packages. Configuration, there's a configuration, a YAML file that allows you to specify the remaining choices. So you can pick a path that you'd like to use for home directories. You can enter the information to configure Google Analytics, to configure New Relic monitoring. You can set up user accounts, so whitelists for system administrators, for instructors, graders, regular user accounts. You can list a set of users that want to have public key-based SSH access to the server for sort of admin usage. You can specify a list of mount points for the servers. You can call idle servers and configure all of that, and then optionally set up a public HTML directory for all users. And so even within the overall constraints, there's still quite a few choices, and we've encoded all of that in this YAML config file. Future work, right now we're just running a Python 3 kernel on this, and so some effort would be required to add other kernels to this setup. We definitely plan on following the JupyterHub services work, and most of my deployments have been done on Rackspace using their bare metal servers. Part of what is working really well with that is that the sort of cost model of those bare metal servers works out fairly well in terms of overall RAM, number of cores, but I also find that the automated backups available on Rackspace are fantastic. Within a few minutes in their web user interface, I can configure backups to run daily, and it works very well. Min, have you ended up trying this now on Amazon or other services?
No, I've only done it on Rackspace, since that's what our accounts are set up with.
Gotcha.
A major factor on the deployment time is the two limiting factors are generally network downloading and packages to install, and then SSD disk access. So Rackspace on-metal servers have really fast network and really fast SSDs, and that's a major factor in how long it takes to do a deployment.
Yeah, no, that I definitely would advise running JupyterHub on SSDs, both from the server perspective and also from the perspective of providing sort of robust, fast access to users who are going to be hitting the file system often. One thing I wanted to comment on is, and again, this is my own personal perspective, other people here are going to talk a lot more about Docker. I spent a bit of time, enough time looking and evaluating Docker for this usage case, and given my constraints, Docker would have complicated things dramatically. And I think it would have turned something that was feasible for a non-DevOps person to do into something that you really had to invest a lot of time in. That's not to say that I think for other usage cases, Docker is absolutely the right tool for the job, but I think it's important to note that depending on your usage case and your resources available and the skill set and the time investment, Docker may complicate things dramatically. Part of that is the current way that JupyterHub and NBGrader are architected. There's a lot of additional hoops that you have to jump through right now. With the new services architecture that's coming up in JupyterHub, I'm expecting that a lot of that is going to improve dramatically. And so we may eventually get to a point where even for this usage case, Docker is a good option. But I think today, given the current model, it's not the best solution for this type of deployment. So I'm going to switch over here to this is the GitHub repository that we have. So it's on the JupyterHub org, JupyterHub deploy teaching. The name is it is optimized for teaching, but again, it would work very well for any context that has these basic constraints, even if you don't want to use NBGrader. All of that's completely optional. The main configuration is done here in the host vars. And so here's the YAML. You can set the home directory for users. There's admin users here. You can set up just sort of the regular JupyterHub users. There's NBGrader configuration, and then things like mount points, the let's encrypt information. There's the public HTML directories, GitHub usernames to have SSH keys installed, calling available services, Google Analytics, New Relic, the GitHub OAuth, and then this right here, I don't think we're using any significant way right now. And so basically, it's a question of making those decisions, editing this file, and then pressing just running Ansible. And so far, this approach has worked very well, given this particular sort of set of constraints. That's all I have to cover at this point. More than willing to answer questions about sort of how we're going about this.
I did want to make one quick comment about the Docker complicating things. I think it's specifically the NBGrader moving files around.
Yeah.
Is really JupyterHub in general. Docker's often the easiest way to do it.
Yeah.
But for the NBGrader stuff, Docker gets in your way quite a bit. And part of the point of the services in general, and the sharing service in particular, part of the point of that is to make NBGrader on Docker easier.
Yeah, absolutely. Sorry, it wasn't quite clear about that. But that's definitely true. And part of where a non-Docker approach starts to really be painful is if you want to start to add other kernels. Then Docker really starts to be fairly attractive, I think.
So just a quick question. The new services architecture that I've heard mentioned a couple times, is there any online or documentation for it that we can go look at? What's planned, I mean?
There's some bullets on the roadmap repo about it.
I'll take a look.
Other questions?
A quick question about the UNIX accounts. How do you guys provision those? Are those from a pool of kind of temporary accounts, or?
So on this particular server, the assumption is that those are truly persistent. So, I mean, you should, now there's a couple options. So if you're not, so this deployment, you don't have to use GitHub OAuth. In that case, when you list users, we actually create those Unix accounts, and the name of the Unix account actually matches the username of the user. When using the GitHub OAuth approach, the user's account name matches that of their GitHub username, and they're not in any way temporary accounts. It would be, for example, perfectly acceptable to deploy this on a system where users already had persistent Unix user accounts. Like that's very consistent with this model and would work quite well.
Right. Well, I guess my question was the other way around. How do you have to provision those accounts ahead of time?
No, that's there's configuration options in a couple different places, and they're already set up correctly for this. And if the user accounts don't exist, they will automatically get created with the right options. And that's, for example, why you need to specify the home directory, because when those user accounts are created, we'll make sure that they're created in that home directory if they don't exist.
As a point of can you hear me?
Yes.
As a point of clarification, when you said new kernels, the support for new languages with Python being the default, is that what you meant by new kernels?
Yeah. So right now, users only have Python notebooks, Python 3 notebooks as an option. If they wanted to use R or Scala or Julia or other languages, we'd need to work a little bit more on the Ansible roles and add that.
You manage your whitelist of students manually just to the admin web interface, or have you come up with a better solution than that?
Yeah, so typically the first day of class, our classes are not too big, typically below 50 students. I will typically run, like the day before class, put out a Google survey where I have the students enter their university username and their GitHub username. Before class, add the GitHub usernames through the UI, and then in class, I have the students just verify they can log on and debug any options at that point. Or, yeah.
Do you have issues with your students putting in the wrong usernames? Because I did that too, and I had a lot of issues with that.
Yeah, students will enter the wrong usernames in any possible way you might imagine, whether it's a different case. And so that is something that I always have to go over the first day. Like I basically walk around with my laptop and talk to every student. We're in a lab type setting, and I just say, hey, can you log on? If not, let's debug it right now. And it is, yeah. Yeah, and part of it is, like, I think experienced GitHub users are familiar enough and know, like, yeah, that this username is going to be looked at by lots of people, and so I want it to be sort of a consistent case, no weird characters, etc. And I find oftentimes in this type of context, students are creating GitHub user account for the first time. They're using weird cases. They're using special characters. Basically, things that tend to cause problems. Part of the issue originally was that the regular expression that constrains GitHub usernames is quite different from the regular expression that constrains UNIX usernames. And in general, GitHub is more liberal than default Unix username conventions. I think we've worked out all those bugs and are setting it up so that basically any valid GitHub username should work. There may still be some edge cases we're not covering, though.
John, did you have something you wanted to add? De Niro?
Yeah, no, that was quite helpful.
Great.
So in the interest of time, I think we should probably continue with Jess, and if there's more discussion, we'll leave it for we have a little bit of slack because we had one cancellation, but we're eating into our slack. So I'd like to, if that's okay, Jess, to continue. And thanks a lot, Brian. That was great.
Yep.
Jess,
Sure.
you want to share your screen? You have the floor.
Okay. All right, can you see my screen?
Yes, we can see it perfectly, and it's here on the recording, so you're good to go.
Okay, you can still see it? I switched to presenter view.
Yes.
Okay. All right, great.
Good.
Okay, so I'm going to talk about, I guess, like sort of the next step. So Brian's class size, is like less than 100. I'm going to talk about scaling it up to about 200 students. And we did use Docker. And so I'm going to talk about like sort of what challenges that satisfied and, what challenges is satisfied and also what challenges we had to overcome with that. So the problem for our particular class, which is taught at UC Berkeley, was that we had 200 students and we didn't want to deal with the local installation of the notebook for all 200 students. So we decided we wanted to use a hosted solution like JupyterHub. But we also had this constraint that, like Brian's class, students had to have persistent files, and they had to be files on a real file system. But unfortunately, like 200 users means that all of the users probably can't be on the same computer. So that was one particular challenge. We also had the constraint that students shouldn't be able to see each other's files. And then we wanted to integrate with services like MBGrader. So this is sort of like, an overview of the issues that we had to solve with this deployment. And so I'm going to break this talk up into sort of two parts. The first is on how we actually scaled out this deployment using Docker, and then how to actually integrate JupyterHub with services like MBGrader. And I'm going to, Min sort of alluded to some of this stuff in his talk. I'm going to talk a little bit more about that. This is not the official service API. It's just, if you're building your own auxiliary things, how you can do that. So to start out with the scaling up with Docker. So the first challenge that we wanted to address is this issue of isolating the users from each other, because they were supposed to work on their problem sets independently, so we didn't want them to be able to see each other's files. So the solution that we had for that was to use Docker, because then that gives each user their own nice isolated environment. It also set us up to solve challenge 2, which was to actually scale it up to the full number of users that we had. And like I said, that's too many to fit on just a single computer. And so we somehow had to scale out JupyterHub to go, to be distributed across multiple computers. And so the way that we did that was to use Docker Swarm. And the nice thing about Docker Swarm is that it kind of just acts like Docker. So for each of the node servers that you have, you run a Docker daemon there, and then you tell Swarm about those node servers. And then you talk to the Docker Swarm application just like you would talk to the normal Docker application. And so you tell it to start up a container, and it'll pick one of the node servers and start up the Docker container on that one for you, rather than starting it up on the local machine. So it's actually like a really nice interface, and it doesn't really require very much overhead beyond just using regular Docker. However, so using Docker, and this is sort of, one of the complications of Docker that Brian was talking about is that, with Docker, like even if you're using Docker, if you're using it on a single machine, you can just mount users' home directories into the Docker container, and that's fine. But once you start distributing across multiple machines, then you need the files to be the same regardless of which machine the student's server is running on. And there are options for doing this that would probably be simpler. So you could like store the user's notebooks in maybe like a Postgres database or something, rather than having them be real notebooks on a real file system. But for our class, we had the constraint that we wanted it to be a real file system because we had exercises that involved file I/O. We wanted to use MBGrader, and so we needed it to be a real file system. So to solve that, we used NFS. And so to take a look at sort of the big picture of how this whole deployment looked like, we had a few different machines. The first was the hub server. We also had the node servers and a file server. So this is, if you've seen me talk about this before, this is actually slightly different from the way that I've talked about it before, because with my Rackspace blog post and the talk that I gave at SciPy last year, that was for last spring's class, but we also taught it again in the fall, and I made some changes to the fall deployment. So for the hub server, of course, we have JupyterHub. We switched to using the Google Authenticator because Berkeley uses Google Apps, so we just were able to allow students to use their Berkeley IDs. And then we use the system user spawner to talk to Docker Swarm. So the system user spawner is part of Docker Spawner, and it inherits from Docker Spawner, but whereas Docker spawner assumes that you're spawning these Docker containers that are, sort of like ephemeral. System user spawner will mount like users' home directories into the container, and it's meant to be used for when you actually have system users. So that talks to Docker Swarm, and then Docker Swarm talks to, or it starts at the notebook servers on your various node servers. And then to make sure that the servers always had the right files, we ran NFS. And one of the changes that we made for the fall was to run the file server as a separate server. So we had our NFS server on this separate server, and its job was just to host the files rather than having them be hosted together with the hub server. And then we ran the NFS clients on both the node servers and the hub server. And so in addition to this setup, we had a bunch of also like auxiliary services. So we had this culling service that Min mentioned. We also had a stats service. We had the form grader, which is part of MBGrader. And then we also had Postgres for the JupyterHub database and the MBGrader database. And these services we also ran in Docker containers. So everything that you see here in blue is in a Docker container. And so at this point, you can see it's starting to get quite complicated. And so that leads us to our next challenge, which was how to actually manage everything. And so we also used Ansible, but also we used it with a tool called Docker Compose, which basically allows you to just specify a configuration file with all the Docker containers that you want to run, either the names of the images or a location where the image should be built. And then you can specify all the dependencies between the Docker containers, all the environment variables that you need, et cetera. And it makes it much, much easier to orchestrate something like this whole thing. When you have everything in Docker containers, if you're using Docker Compose, it's just like one command and it starts everything up for you. So that was made it actually a lot easier to deal with this complex deployment. Okay, let me just check how I'm doing on time. All right. All right, so that was sort of the big picture of how we actually scaled this out with Docker. And so the next part I'm going to talk about is a little bit more about these other services that I talked about. So we had this culling service, which the job of the culling service was to shut off single user servers if they're idle. So if the student hasn't accessed the server in a while, it should be shut down. That way we don't, just end up having all of the student servers running all of the time. We had a stats service, which kept track of who was using JupyterHub when, and this gave us a sense of like the load of the system. And then we had the form grader service, which is part of MBGrader, and it's a web application for grading Jupyter notebooks. So the way that these three services work in conjunction with JupyterHub is well, there's a few different things that you can do. So the first question is how you actually talk to JupyterHub. And Min mentioned this. You can use the REST API. So to do this, you first have to get an API token. So you run this on the command line JupyterHub token. That'll give you a token that you then use to access the API. So you can do, for example, a GET request. This gets the Hub API users. So that'll get your list of users. And then you pass in the headers with authorization with the token that you got from the command line. So this will allow you to access the API. In the PDF that I have in the GitHub repository, I said that the API docs were undocumented, and then Min linked to them in his presentation. So I changed it really quickly. I'll change the PDF in the repo, but there are the docs for that API. And both the stats and the culling service use this API to do their thing. And that's really all they do. They just pull JupyterHub with the API, and they don't do anything more complex. Services like the form grader, however, are much more complex because they have to do two things. The first is that they need to run behind JupyterHub, so they need a JupyterHub URL. And then the form grader, we want to authenticate our instructors to be able to access the form grader and not allow the students to do it. So we also need to do authentication through JupyterHub. So to get the URL, you can, so the lights are going off in this room. I don't know if I can, there we go. Okay, so to get your JupyterHub URL, you run your service at whatever URL and port that you want. And then to get the URL, you don't actually talk to JupyterHub, you talk to the configurable HTTP proxy. And so you maybe do a post to the proxy URL at port 8001, and you tell it, I want to create a route for my service. You give it the proxy API token, which you had to set when you started the proxy, and then you tell it where your service is running at. And once you do that, you can access your service at the same URL where JupyterHub is running /my service. And you could do whatever route that you want. It doesn't have to be my service. It could be, like, so it could be like /grader / like class 101 or whatever. So the config proxy documentation is there. It gives some more details on what you can do with that. And then the most complex part, as I mentioned, is authenticating with JupyterHub. And so you have a set of users that you want to be able to access your service, but and so you want to ask JupyterHub whether those users are who they say they are. So to do this, you again get an API token from JupyterHub. And then Min wrote this hub auth surface. So this used to be a lot more complicated, and it still is quite complicated in NBGrader if you go and look at it. But with this hub auth surface, it should be much easier, where you basically can use this this hub auth object to connect to JupyterHub. Ask JupyterHub, is this user authenticated with JupyterHub? And then if they are, then you can use in your application, just say whether or not that user is allowed to enter your application or not. So as I mentioned, the example use case for this is the form grader. And so that is mostly, that's the whole of my talk. I have a whole bunch of links here. I just will go through them really quickly. Min already linked to the Docker spawner and the system user spawner. There's the Google Authenticator that we used, and the reference deployment with Docker. These next links are from my deployment, and they're out of date. So if you try to run it, it's not going to work, but they might still be useful just for reference. So our whole Ansible deployment is there in the first link, and then the Docker Compose template that we used is there in the second link. We have, and then I have a separate repo for each of the Docker images that we use. So there's the one for JupyterHub, the one for the single user servers, the one for stats, culling, and form grader. And that's it. Thanks.
Great, Jess, thanks. Maybe if there's one quick question, and in order to try to stay on schedule, we'll hand it over to Ryan. If Ryan, you want to start getting ready, but if there's one quick question for Jess, and then we'll take longer discussion later in the.
So I've been kind of trying to decide between a setup where I would use a load balancer on AWS EC2 and actually use auto scaling versus a setup where I would use something like Docker Spawner. And part of that decision is actually moving the database and the file system off of the JupyterHub Docker instance and into separate connected services. So I'm curious, why does every piece of documentation that I see about this say use Docker Spawner as opposed to use standard things like auto scaling groups with a load balancer?
I don't know if I'm really the right person to ask that. I don't have actual professional sysadmin experience, so I don't have too much experience using load balancers myself. At the time, when we set up this deployment, Docker Spawner and Docker Swarm seemed to be the right things to use. But it's certainly possible that using a traditional load balancer might be a better option. I haven't explored that, so I'm not sure. Yeah,
it just seems like as far as complexity goes, there's so many tools for both of these things out there. But if you're spinning something up on EC2, you can just set an auto scaling group up and it takes care of all of it for you, as opposed to something like Docker Swarm where you actually have to manually set all of these settings and set up these servers and point things to them.
Mm-hmm.
I don't know.
Docker Swarm also takes care of all of it for you, in the sense that you have nodes and it just puts things places and depending on what it is.
I don't think they're necessarily, you can sort of use both too, because I've seen, especially with some of the newer Docker tools, it will integrate with AWS.
Go ahead.
I was also interested in the ECS setup, right? Like,
Yeah.
there's so many options now, and with a limited understanding of how JupyterHub is actually working under the hood, it's difficult to point to like, oh, this is the best way to scale it.
So yeah, so JupyterHub really doesn't care. JupyterHub says, "Hey spawner, I want a server. Tell me the IP and port where it ended up." And so literally any way you have for starting a process on a computer that's accessible over the network will work.
Yeah.
I
So
think people have ones that'll launch like whole virtual machines, so you can do it without our scaling groups. The problem that you're going to run into is what data is on those nodes. So depending on if you're having to attach EBS volumes or,
so
or
Amazon
if you're
just,
trying to use EFS,
Right.
EFS you're going to run into totally different problems on. The latency will be just terrible. I've been testing in the last couple of weeks.
Yeah.
Just not a good solution right now.
EFS is
Quick question for Jess. How does the out-of-date status of several of these links affect our decision-making?
They shouldn't affect your decision making. I wouldn't recommend like using those things out of the box anyway. That's our specific deployment for our class, and it isn't. It is there for reference, basically. Like, I think it might be helpful for people to take a look at that, and I know other people have base deployments off of that, but it's certainly not something that will work out of the box for someone and is very complex. So like, unless you are trying to do something very complex, you probably shouldn't use it yourself. So it being out of date is, you know, like things like there are like some URLs that have changed. And you know, like the version of JupyterHub has changed, the version of NBGrader has changed. So we did the class in the fall, and I haven't updated the stuff for the next iteration of the class. That's why it's out of date. But does that answer your question?
Yes, thank you.
Okay, so I'd suggest we hand it over to Ryan, and people maybe log in the back of their brains longer questions for the later discussion session. Thanks so much, Jess.
Hi, everybody. Can you hear me?
Yes, we can. We're seeing a blank screen for the moment. So why don't you try to share your slides? And I have them for backup here if need be. Okay, that's perfect. You're on the screen. So
okay,
you have the floor, Ryan.
Okay, great. Yeah, so my name is Ryan Levitt. I'm in the Department of Statistics here at UC Berkeley. And we deployed JupyterHub for a new class here. Foundations of Data Science. It's cross-listed in Department of Statistics, CS, and School of Information. It's unique in that it has these what are called connector courses. So there's a main class, and then there's a series of other classes where students apply the skills that they learn in the main class to discipline-specific projects. So there's one main instructor, but then several connector instructors. And the students are coming into this with no knowledge, in some cases, many cases, no knowledge of statistics or computer science. Like Jess, we didn't want these students to have to install a bunch of software on their devices, and JupyterHub makes it easy to give the students the tools to learn. The first semester where this class was taught, there was about 100 students, and we ran JupyterHub on a local cluster in the Department in the EECS department. The next semester, we had about 480 students, and we chose to deploy on Azure because we didn't have enough compute at the time to continue to run it on a local cluster. We also had we used the local cluster as a fallback to the main instance on Azure. And then in the coming semester, we'll have about the same number of students, and we're also planning on hosting it at Azure. In the future, depending on who you talk to and when, there's going to be anywhere between 500, 1,500 students taking this class. So that relates to scaling, which I'll talk about later. So in our deployment, we had the same constraints as Jess, and so fortunately she did everything. So we just copied her comp models deployment. There as she said, there was a lot of configuration, which was particular to her course. She was hosting at Rackspace, so we ended up moving it in development. Oh yeah, we didn't use NBGrader. And we tested on AWS. That was the first place that we tried deploying. And it took me a couple months to learn about all the particulars. I wasn't familiar with, Docker and Ansible and, the spawners and JupyterHub and all that stuff. So it took a while to learn about everything. And the first semester on the local cluster, it was fairly uneventful in terms of issues we ran into. The second semester on Azure, we did notice some spawning errors. So for example, users would say, I saw an error on the hub, some HTTP 500 error. And so we would need to go into the admin interface and stop and start the user server for them. And there was some variation there, and we were documenting it all. And we sought help from Min, and he got us straightened out there. We had students fall back to the local cluster that we were running the previous semester, and it had a different storage. Each instance had its own NFS server, so we had some complexity that we introduced to ourselves, and in getting the students' notebooks synced with each JupyterHub server. As I said, Min found and fixed all of our spawning issues, such that we ran a short summer course on our Azure instance, and when we updated to the latest JupyterHub 061, again, we haven't seen any issues there, any of the spawning issues. As I said, for me anyways, there was a learning curve to learn all about the tools, Ansible, Docker, Swarm, etc. My background, so I'm a sysadmin, so one could say I should know more about these things, but there's so many tools, and they interoperate in so many different ways that it was interesting, learning about the whole stack. And in deploying JupyterHub, I found that it's very important, particularly since I got it going on AWS and then local server and then Azure, in terms of redeploying it each time to make it reproducible. You have to really pay attention to the versions and the tags on each particular component. So if you say you're using Ansible and you're using the Ansible container to deploy, well, you need to make sure that you're using Ansible 1.9 instead of 2.0, depending upon how you set things up. And everything that you specify in your Docker file and your in your requirements, your conda pip, etc., you should really. I found it's useful to keep track of the versions there so that it can be reproducible. We're looking in the future, so we had a group of students doing learning about JupyterHub and helping us with sort of corner issues, and we one student has started to develop a system for stress testing the hub with Selenium. So next semester we'll pursue that a bit further. Continuous integration, that's something that I think people are doing in a lot of places. That's something we need to be doing more of, and I need to be learning more about to make this whole process more seamless, more reliable. And as was mentioned previously, there are these reference deployments which have come out, and I may look at rebasing our deployment on those to reduce the deployment-specific stuff that we have that we don't necessarily need now that these reference deployments are out. So one thing that was important to us, to the instructor, John Dinero, he wanted the ability for students who were perusing the course text to be able to click on a button in the text and have it appear in the JupyterHub. And so that's the way that we are distributing notebooks into the students' accounts. So we wrote this, a student wrote this service we're calling Interact. It's a hub-side service. We stole some of the code that just has an NV grader and some other places done for how to implement a hub-side service. And so that when the students click on the link specifies what GitHub repository the notebook can be found at, and the hub service pulls it down into the student's account. It'll also start up the student's server if it's not already running. The downside is that not all of these connector course instructors are familiar with Git. They may be history instructors or English instructors. And so they may not have training in how to use Git. So we're looking at other ways that we can distribute notebooks to our students. The other issue is what happens when these notebooks change that are being distributed, and when the students make local changes, how to sync them up. The Postgres Contents Manager, I think it does cell-based notebook storage, so one could alter some cells and not the other. I don't know if we'll end up going that route. What we have looked at most recently is Jupyter Drive. So that would protect us to some extent if we did have multiple hubs. It gives users the same storage via the Jupyter Drive. Berkeley integrates with Google Apps. So everybody already has an at berkeley.edu Google Drive. We just brought this online this last week, I think. And we'll need to do some testing to see how it operates in terms of local data file access, sharing, and that sort of thing. What happens? Anyways, it'll just require some testing. One interesting thing is that we could potentially integrate with the Google Drive UI. So somebody could have a notebook in their Google Drive, and then they could say "open with," and it'll open on our hub. So that's something that we may explore. The one question that the faculty have said that is important is how do we get an IPyNB that can be hosted anywhere on the internet into our hub? I mean, we could pre-populate these notebooks on the system ahead of time, but it's important that they could specify a URL or some such thing and automatically easily import it into the hub. So Min's bullet point about content sharing, we're definitely going to be paying attention to all of that.
Brian,
so,
I want to second that. I think it would be good to have a way to pull in existing notebooks into the hub in a really seamless fashion. Right now, it's a bit of a clunky approach where you cut and paste stuff and.
It's not a hub thing. It's a notebook server thing directly. Right.
Yeah, their Interact solution.
I'm sorry, I can't hear Fernando.
Sorry. Yeah, that solution is actually quite seamless. It has the constraint that it assumes the content is on GitHub, but it's a very good starting point. I've seen it on the user side, and it's completely seamless. And actually, because it's just URL based, if you realize, oh, I need this other thing, you just go and hack the URL. You give it a path, basically the reference on GitHub.
What is it called?
It's called, I think, Interact. The Interact.
I'll send you a paste into the chat channel, maybe the that. We're actually looking at redoing some things with it, version 2.0 for this semester, but the previous version is pretty straightforward. It's a Tornado. No, it's not a Tornado app. It's a I forget what it is, but because of this new hub side service feature that's been created recently, we're going to rebase on that and provide a little bit more feedback for when the Git pull takes a while. We need to provide some feedback for that, but it works well enough.
That's useful. Thanks.
Sure. So because we had multiple instructors, some of them, were fine with the single user Docker container environment. Others wanted, they requested additional libraries to be installed, and so we needed to be able to find a way to enable those faculty to deploy that software, to test it, and because the single user server doesn't give students the ability to become root, it doesn't give the instructors the ability either. So we basically, we've derived our system user container so that if people want to, they can run it on their local computer using Docker Beta, or I suppose even any version of Docker, but so that they could pull that system user container down, have the same environment as in the course, but they can install libraries and try things out. I'm sort of thinking about having giving people the ability to choose which image they want to run on the hub. So a student may only have one choice on which container to run, but an instructor, it might be handy for them to be able to start the student type server, or a variant that gives them more privileges. So I'm playing around with this thing I'm calling image spawner, which basically just gives you a form to choose which Docker image you want to start up. Yeah, so let me just skip all that. So scaling, so here we're thinking about how to support, in the context of the data science education program, we have a number of these connector courses, but a lot of people are starting to pay attention to the JupyterHub and what it can provide people. And so we're trying to think about how we can support multiple courses. Do we, have one hub with multiple spawners, or do we have one hub, one course type of arrangement? How to scale compute? Do we stick with Swarm, or do we look at Kubernetes? UV Panda, who's at Wikimedia, I had a chat with him, and he seemed very excited about what Kubernetes can do, and its ability to scale onto multiple nodes. We want to be able to look at. Right now, we're creating nodes rather than dynamically creating them on demand. So it's a bit wasteful. And there's this question about how well JupyterHub itself scales. I think we're maybe one of the larger deployments out there. In the JupyterHub docs, it says that JupyterHub is for modestly sized groups of users. So I don't know if we're modestly sized. So I think we need to start collecting the data about how long it takes a container to start up, how long it takes to for a user to log in and whatnot. And so Min and UV have added the StatsD tooling, and so we want to start collecting that so that if we do have some sort of issue, and we can call out for help, so that we'll have this data to show to the JupyterHub devs, this is the problem we're seeing, and this is how the hub is behaving. Future direction. So right now we're just going to keep on going with the hub. And if we have more users, we're going to see if how to deal with it. We'll try to knock down the issues as we come across them. There are these newer, notebook as a service kind of efforts emerging. Microsoft has their notebooks.azure.com service. There we don't have to create the infrastructure, the Docker swarm, etc. But we don't have control of the server side that JupyterHub gives you. We can't run these hub side services. And it requires that each student have a Microsoft account basically already, and so we can't tell our users go sign up for Microsoft before the course starts. CalNet may have our local Windows team may have some help for us on that front. And then there's other services like MyBinder, and that's helped faculty do some development in terms of customizing their Docker images if they want to try out something. I think Min had a talk in London, and where he proposed a notion of you can create a spawner that operates in the same way as Binder, and that kind of feature may be useful. So I was talking really fast. I don't know if I've covered everything, but the links we have here are the last one is the textbook by John DeNiro and Aniota Kari. And the first two are information about the data science education program. I didn't go into too much detail about our deployment, again, because we pretty much copied Jess, tweaking it for the local service provider. And that's it.
Thanks, Ryan. No, that was great. And actually, timing-wise, we basically ate into all of our scheduled slack, and we're already 3 minutes technically into the 10-minute break. So if there's maybe one quick question, otherwise I would say I would stop the recording to give people a chance to take a quick break, and then we would resume in a few minutes.
If I can ask a real quick question, what do the English and history people use with Jupyter Notebook?
Yeah, so that's so I'm not heavily involved in the pedagogy. John Gennaro, who I think is on this call, may be able to chime in more. But they have interesting projects where they're using data science, history. I think they were doing. I think it was an evaluation of the slave trade. English. There's certain things that can be. Ascertained about word simple as words in a book. What information you can extract from just the raw the raw words that can be found in any piece of literature. John, are you still here?
Sure, but it's hard to give a succinct answer. But there's lots of things that people have discovered. So yeah, I can follow up with you if you want.
But I would add that the short answer is to go to the data.berkeley.edu link, and you can see that if you click on the connector courses, you would see that there's actually a number of courses that are in the digital humanities. There's and other areas. There's a data and ethics course. There's a literature and data course. There's a how does history count course. So there are a number of courses of connector courses in the education program that come from the humanities and the social sciences, fields that traditionally haven't been using these tools as much. And so there is a fairly active kind of ecosystem here at Berkeley of courses in those areas. And the education program is open. The foundational course is open to all incoming freshmen, regardless of their declared major. And so it really is aimed at a very broad population.
Thanks.
So I would say that we should probably take a little break right now, and let's start again in 10 minutes to keep the break to be actually 10 minutes. I'm going to pause the recording. Thanks, Ryan. I'll restop the recording afterwards.